Hey guys, and welcome back to a new video. In this video, I want to give you a different idea, a different approach to navigation on Android with Jetpack Compose. And this is really meant to be just some food for thought. If you like it, feel free to stick to this approach in your project. If you feel like you'd rather stick to the conventional approach, that's also totally fine. But the approach that I will show you here will allow us to do something like this, that if we have a view model, we have some sort of navigator in there, we can then very easily use to navigate to wherever we want. Because normally we only have access to our nav controller inside of our root composable and not inside of our view models, but very often we need to trigger navigation transitions from our view model. And the typical way for this was then using some kind of one-time event with a SharedFlow or a channel, which was then listened to in every single of our screens. And this approach that I will show you here will use a comparable approach, but work globally for your whole app. So we will just have that navigator singleton, which you can inject wherever you want to navigate from, and then simply use that as if it was a nav controller without actually coupling our view models to the real nav controller. So you will see how this works. So whenever I click here on login, and for example on go to detail screen or just go to home, all these navigation transitions were triggered from our view models without us having to explicitly listen to these navigation actions and events on every single screen separately. Another advantage that this approach that I will show you here has is that it will also make UI testing easier, but I think it will make more sense when I talk about the reasons here once we get to that point and actually implemented a bit of code here so you understand how this works and then also why this makes UI testing easier. Alright, so all I've done for now is just really added the dependencies, set up a very initial project here where I've added these. So specifically that's compose navigation, that is Kotlin X serialization JSON. So we can use the new type safe navigation approach from Compose, and I will use Koin just as a very simple dependency injection setup, so we can also inject this navigator instance across our project. I've then already added everything here in our build.gradle file, and you can just clone the initial branch from GitHub down below. And then you will have exactly what I have here, and we can dive into the code right now. Let's minimize this, and let's first of all start to define our different destinations, so where we want to be able to navigate. So in our root package, let's create a class called destination. That'll be a sealed interface. Yes, let me add that to Git. A sealed interface for every single destination we have in our app. So this could either be a screen or simply a nav graph, which bundles multiple related screens. So for example, we might have a data object for our home graph. So where we get to after logging in, which is a destination. And we need to annotate this with serializable, so it is recognized as an actual route where we can navigate to. And we might want this for the auth graph, which is also a destination annotated with serializable. And each of these two graphs will then host a certain number of screens, for example, a login screen. Make this a destination, and again, say that's a serializable. We can do the same for home and for detail. So we have a home screen and we have a detail screen where we might want to pass an argument, so you can also see how this would work. So in that case, this would be a data class with some kind of ID we maybe clicked on or so. Furthermore, what we need is we need another sealed interface that defines the different navigation actions we might want to perform. So this could just be navigating to a new route, but it could also just be popping the backstack to get to the previous screen. So here in our root package, we want to create a navigation action sealed interface, which on the one hand consists of a data class called navigate, where we now pass our destination, so where we want to navigate, as well as optional nav options. And that's really just a lambda that extends nav options builder, since that's exactly the format we also get from the nav controller when we can configure the navigation transition. For example, if we want to pop the backstack up to a specific screen, that will then be possible with this nav options builder. However, this is optional, as I said, so we can set this to an empty lambda by default. This navigate action should then be a navigation action. And we will have a data object to navigate up, for example, so to get to the previous screen. This will also be a navigation action. And maybe you need a few more actions here if you want to explicitly also have one for popping the backstack where you don't want the navigate up behavior. You could of course extend this very easily. And now with these two actions, we can create our navigator instance. So that will really be the core or the heart of our navigation approach here. So pretty much our own kind of version of a nav controller, which we are however able to just manage on our own, provided as a singleton with Koin, and then injected in our view models, for example. So here we will create a navigator, which will be a normal interface. That's important that we make this an interface and then have an implementation of that, since otherwise we won't be able to maybe swap this out. For example, if in a test case, we might want to have a different navigation approach, a different navigator with a different start destination or so. As I said, you will see at the end of this video how this can really help with UI testing. In our case, every single navigator will have a start destination, so a destination. It will have a navigation actions shared flow, which consists of navigation actions. So the shared flow is just a hot flow where we can then send these single navigation actions into, so navigate or navigate up. And since it's a shared flow, it can have multiple collectors, so multiple single units that listen to these navigation actions independently. And then we can simply provide functions, actually suspend functions, to, on the one hand, navigate to a certain destination together with some optional nav options. So nav options, which are in the same format as before. So nav options builder, and just a lambda, which we set to an empty lambda by default. And we want to provide a suspend function to navigate up. And this is really already our little navigator unit with everything that we need for navigation. Of course, in certain scenarios, you might want to also have access to more properties, more fields of a nav controller, like the saved state handle, maybe the previous backstack entry or so. In that case, you could, of course, pretty easily extend this approach. But so far, this is just an abstraction. It does not really define how navigation works. So we also want to define a class down here called the default navigator. And this will override the start destination in our constructor. So we need to pass this from the outside. We can determine this wherever we create this default navigator instance, like in our DI module later on. And this will then implement the navigator interface. In here, we can then hit Command I to override all these different fields. And here, first of all, for the navigation actions shared flow, which we will then use to observe these navigation actions that could be sent from anywhere. That's really the whole point of this approach. Here, we want to have a private property underscore navigation actions, which is a mutable shared flow. So one where we can actually send something into of type navigation action. And this navigation actions public shared flow will be an immutable one. So we can directly send these actions from the outside, which is typically considered a best practice, since then if there is a bug, we only need to search for issues inside this class and not in other classes that might have sent something directly into this one. For the navigate function, let's go ahead and we say, whoops, our navigation actions shared flow, and we emit something in that shared flow. So we just send this action inside there. In this case, it's navigation action dot navigate, and we pass in our destination as well as our nav options. For navigating up, that's even easier. We say navigation actions emit, and we emit the navigate up action. Something that we have to consider here is that we shouldn't just use a normal mutable shared flow, but one where we actually assign a replay of, let's say, 10 and an extra buffer capacity of, let's say, 10. Because shared flows have the issue that events could possibly be lost if there is no active collector of these. So for example, if our UI is in the background and a navigation action happens in our ViewModel, for example, then there is no collector of this shared flow, yet the navigation action will still be sent into it. And if there is no collector of this, well, then we will lose the navigation event and the navigation will never happen. To fix this, we will assign a so-called replay cache. So the shared flow will cache up to 10 emissions, in this case, up to 10 navigation actions, and then actually replay these when another subscriber appears. So when our UI comes back in the foreground, for example. When I think about that, we might actually rather use a channel here rather than a shared flow, since as the name says, a shared flow is meant to support multiple collectors. But in this case, we only want there to be a single collector, which is at the root of our navigation graph, just where we have access to our nav controller and where we can then trigger these navigation actions. Because if we would have multiple collectors of this shared flow here, while having a replay cache, then as soon as another collector appears, that collector would get all the actions that the previous one might have already handled. And that's not what we want, of course. So let's rather force this single subscription behavior here by using a channel, since a channel is really similar to what a shared flow is, just that it's meant to have only one subscriber. So only one unit listening to these navigation actions. We can also make this of type navigation action. And instead of using as shared flow, we say that receive as flow. Here, instead of emit, the equivalent is that send. And we also need to make the shared flow a normal flow. And then we easily migrate this to a channel, which will also come with an integrated buffer. So even if we send events and actions into this channel in the background, when there is no subscriber, then the channel or this receive flow here will cache these as well. So next up, now that we have our default navigator class, we can set up a Koin module. So just a place where we can initialize the singleton for the default navigator. Let's just create a DI package, an application module in there. Just make this a file, call this app module, and make this a Koin module. In here, we can say single. So I want to create a singleton, which provides a navigator instance. And in here, we simply provide our default navigator. The start destination in our case is destination from our own app auth graph. So the authentication graph that has the login screen as the initial destination will be our start destination for the whole nav host. Then we will also need to create an application class in order to really initialize Koin. So we can say, yeah, let's just call it my app application. And then on create, we can then initialize this whole thing. So we can say start Koin, assign the Android context, which is just the application class. We might want to pass an Android logger, but most importantly, we want to link the application module we've just created so Koin knows these dependencies. We can then go in our manifest, open this, and also reference this just created application class. And of course, if you're new to Koin, then feel free to, of course, watch my free YouTube video about that. But since this video is not primarily about dependency injection in Koin, I won't go over every single detail here. All right, next up, now that we have Koin set up, we can go to our activity. And here in our scaffold, we can then create our nav host. This one here takes in a nav controller and comes with the start destination. We can create our nav controller, set this to remember nav controller, and then pass it in here. The start destination is, well, the start destination that we've chosen for our navigator instance. And we can now retrieve this by using Koin. So val navigator is equal to Koin inject. And we want the object that has the class navigator. We can then say navigator.start destination. So by saying Koin inject, we really just tell Koin, hey, I want the object navigator here. Please inject it, reference it here, and then we can use that to assign the start destination that we've set here in Koin, in here, the auth graph, to our nav host in here. Inside this nav host, we now just normally set up our navigation. So since we have two navigation graphs, we need the navigation function here where which one describes the auth graph, first of all. And the start destination of this auth graph is our login screen. And here we can then have a composable for this login screen where we really just want to have a box with a modifier fill max size with content alignment center. And in here we can then display, let's just display a button that when we click that button, we will actually perform the navigation. The text can say log in. And clicking this will then trigger a function from our ViewModel so that you can see that we can really navigate from the ViewModel. Well, let's first of all finish our navigation graph. So we can copy this, put it down here, have the same for our home graph. Here the start destination is simply our home screen. This should be home screen. And when we click this home screen, click this button on the home screen, we go to detail. And we need one last composable for our detail screen in here. Detail screen. Here, we do need certain arguments. Since the detail screen takes an ID, we can extract these with it. So our nav backstack entry, .toRoute. I want to extract the detail screen out of that. Here we can then display a column, since we need text and a button. Actually, not this one. This one should be a column, where the content alignment can be swapped out with vertical arrangement center, horizontal alignment of center horizontally, and then above this button, we have our text where we say the ID is equal to args.id. Here on this button on the detail screen, we can then say go back. And now the last thing we need is actually just set up our ViewModels, inject our navigator instance in there, and then perform the navigation from inside the ViewModel. We can, by the way, also use this inner padding here for the nav host, so it doesn't complain anymore. Modifier padding and pass in the inner padding. Okay, let's create a login ViewModel. All these ViewModels will be super similar. Just make this a normal ViewModel instance. Here we now want to pass in the navigator reference. And when we then perform the login action, we can just say we launch a coroutine in ViewModel scope, and we use our navigator to now navigate. So navigate, and we want to navigate to destination.home home graph in this case. So when we log in, we want to get to the home graph. And we also want to pop the auth graph from our backstack. And that can be done with these nav options. So you've also seen that, where we say pop up to a certain route. So destination auth graph in this case. And we say inclusive is true. So we will pop everything up to this auth graph, and the auth graph is also considered then also popped. And then we can just take this login view model, copy paste it, make one for the home screen. We can say, okay, navigate to detail with a certain ID maybe. And then we can say we get to the detail screen with our past ID. Here we don't want to assign any nav options. And when we then duplicate this login view model once more for the detail screen, just detail view model, then we have a function to go back, where we don't want to call navigate on our navigator, but rather just navigate up. All right, we can then go to our app module, actually provide instances of these single view models, so we can also inject these with Koin by simply saying view model of login view model, put a double colon in before, and then Koin will automatically figure out how to create this view model as long as it knows all the dependencies that it needs, which is just the navigator. We need this for home view model and for our detail view model. All right, now we are able to go back to our activity and inject all of these view models. So very easily by saying our view model is equal to Koin view model here. And on the login screen, we want to have our login view model, of course. When we then click this button, we want to say view model log in. Same can be done for the home screen, where we want our home view model. Here we would say here we actually need to use this lambda as it is, because we need to pass a parameter. So navigate to detail, and the ID can be just some random UUID, for example. And lastly, here for our detail screen, we use the detail view model. And when we click on our button, we say view model, go back. One last thing we now need to do is, of course, listen to these navigation actions that we get from our navigator. So here, this flow that we get, right now we of course don't subscribe to that and listen to these actions and then delegate these calls to our nav controller, which will really perform the navigation. And for that, I will create a little utility composable called observe as events, which I've already went over in quite some videos. And I also have a dedicated video about one-time events and which types of one-time events are an anti-pattern, how you should do that. So if that interests you and you want to understand this composable in detail, then please just search for something like one-time events anti-pattern compose or so on my channel, and you will find this. We'll call this observe as events, and it's really just used to observe a flow as events, so as one-time events, not as a persistent state like we would get with collect as state. We need to pass in the flow. This is actually a generic function. Need to put this before the function name. Flow of type T. I need to import flow from Kotlin coroutines. We might want to pass some optional keys, which are null by default. So these will simply re-trigger collecting this flow. And we need an on-event lambda, which will give us instances of the events that we observe here. And in here, we will really just have a lifecycle owner, which is our local lifecycle owner.current. And in order to now observe these one-time events in a lifecycle-aware manner, we make use of a launch defect block. We pass this lifecycle from the lifecycle owner, as well as our two keys, like this. And in here, we can then say repeat on lifecycle, actually our lifecycle owner.repeat on lifecycle. And when the lifecycle is in the lifecycle state that started, then we want to recollect the flow here. So this is just a utility function that comes from the lifecycle dependency from Android X that lets us really collect flows in a lifecycle-aware manner, so that it will stop collecting when the app is in the background and restart collecting when it comes back to the foreground. In here, we then switch the coroutine context to dispatches main immediate, which is kind of a special main dispatcher and used as a trick here to really make sure that no events can be lost. That's really something I went over in a lot of detail in this separate video just about this function. And here we can then finally collect this flow, where we pass in our on-event lambda. So whenever this flow receives an emission or is triggered, we will call this on-event lambda with this specific emission. So this T in our case will just be a navigation action. Here in our UI, we can then make use of that, observe as events, to observe the navigator navigation actions. And here we then get each action in this Lambda block. So whenever we navigate, this block will be called, and here we can then check what that action actually is. I'll enter to add the remaining branches. If it's navigate, we use the nav controller to navigate, in this case to the action.destination, and here in this Lambda block, we can then pass the action nav options, and we call this with the nav options builder, which is simply this. So the reference here inside of the scope. So we can reference this, and then we have access to that in the Lambda as well. Navigating up is much more easy. Here we can just say navcontroller.navigate up. All right, so quite some setup in order to make this work and make it very easy to navigate from across our project, but most likely from your ViewModels. That's really the only place where I would recommend navigating from, or from your UI directly, of course, but not maybe from your repository or so, since that's data layer that has nothing to do with the UI, has nothing to do with the navigation. And even though you could navigate from there with this approach, I would highly recommend or advise against that. So let's launch this and see if this works. And if it does, I will talk about why this might be better or more intuitive for UI testing. I've launched this here. This is still the old version. Gradle is still running for a moment. So there we go, it's now launching. Here's our login button. And if we click this, yes, then our navigation is actually performing. Here we are on our home graph, and you will also notice that if we go back, then our app closes because we also pop the backstack up to the auth graph. So this works perfectly fine. Let's also test the remaining navigations. So login, go to detail. Here's our random navigation argument that we've passed. We can go back normally to the detail screen or by clicking on this back button, which is then triggered from the ViewModel. All right, so why is this approach so cool? The thing is, in UI tests, we of course have to run some kind of activity that really contains our UI that we want to test. And very often for end-to-end testing, we want to test multiple screens together. But by default, if you would really just have your start destination here in the nav host, like destination.auth graph, then that is pretty static. Because for the production app, of course, your app always starts in the auth graph or in the login screen if the user is maybe already logged in. But the start destination is always pretty static. But if in our UI end-to-end test, we want to maybe test a group of screens that the user gets to much later in the navigation flow, then there is no really easy way to actually instruct the UI test to start on these group of screens. Because in our UI test, we don't have access to this nav controller, since it is retrieved inside our set content lambda here and has to be created with remember nav controller. And when we just run our main activity from the UI test, this part of the code we have no influence on, at least without using any hacky and ugly workarounds. So for the UI test, we would always start on the auth graph, and we would then first of all need to make sure that we somehow get to the screen or the group of screens that we actually want to test. So this might be putting some kind of token in our local preferences so the app thinks the user is already logged in. And that means maybe simulating some clicks on some kind of icons that actually lead the user or the UI test to the screen that we want to test before we can actually even put our test instructions. But with the approach that I've shown you here, by using this navigator, we can just use a custom navigator instance, since that is an interface. We can just create our very own fake navigator or test navigator, where we pass in our very own start destination and also control that from within the test case to decide where we want to start the test case in this end-to-end test. And from this point on, it's just really easy to navigate from any ViewModel in your app, because all you need to do is you need to pass this navigator instance to the constructor of the ViewModel, and then you can just call navigate in here. And you also don't couple your UI-bound nav controller to your ViewModels, because that's simply not used in the navigator interface. Really just references the destination and navigation action, which are our own classes. So this isn't coupled to the composed navigation framework in any way. Or maybe with the nav options builder, to be fair. But if you wouldn't want that to couple your ViewModels to the composed navigation framework, you could also easily create your own set of classes that can be used to configure such a navigation transition. So that wouldn't be a problem to set this up here as well. So I hope you enjoyed this. Down below, you will find a link to more advanced Android Premium courses. So if you want to really take your skills to the next level, get ready for the Android industry, then these courses are the way to go. Specifically, I could recommend my Android Essentials bundle, where you will really build a huge app with, I think, 10,000 lines of Kotlin code. So do check this out. Happy learning. And other than that, thanks so much for watching. I will see you back in the next video. Have an amazing rest of your week. Bye bye.